Which is okay. I mean, if you don't want to listen to me talk, I don't want to see your face.
Damn.
I'm kidding. I mean, I don't want to see your face. Okay. So, I mean, if you don't want to listen to me talk and you just want to pay my salary, that's fine. That's okay. I still get paid either way, guys. Let's talk about loops again. We have a couple of different types of loops we're going to start getting into now that we have some more complex data with arrays to mess with. The first thing I want to do is I want to talk about a type of loop called a do-while loop. So in your standard while loop, we check a condition, and then we do the body of the loop, and then we check a condition, and then we do the body of the loop over and over again, right? A do-while is the opposite, and that's the only difference. We do something, a block of code, and then we check the condition. And then we do a block of code, and we check the condition. So the only difference is that with a while, we check the condition first, and with a do-while, we check the condition last. That is the only difference between us. So let's go ahead and go through an example. So here I have a while and a do-while loop. We're going to have a counter that we start at 3, and, oh, I messed something up. We're going to have a counter that we start at 3, and while that counter is greater than 0, so for the values 3, 2, and 1, we're going to execute this loop. So the first iteration of the loop, it says she's dead, Jim, and then we subtract from the counter. Yeah, I like Star Trek, so give me the hints. And then, so now the counter goes from, oh, this is totally out of order. Okay, I'm just going to put this all on the screen. Apparently that's just a mess. I guess I messed up this slide, so I'm just going to put it up here and we'll go through. Okay, so the value of the counter starts out at 3, then we say she's not dead yet, Jim, and then we subtract from the counter. So now the counter's value is 2. And we check the condition again, it's still good, so we say she's not dead yet, Jim. That's the second one, and then we subtract from the counter, so now it's 1. 1 is still greater than 0, so we say she's not dead yet, Jim. And then we subtract from the counter is now 0. 0 is not greater than 0, so the loop terminates. And then we print out, okay, now she's dead. Then we go to the do-while loop. So, whoops. So in the the day is getting late. So in the do-while loop, we're not checking the condition at the beginning. The first thing we do is we print out looking for vital signs. And then we increment the counter. So in this case, the counter is going to go up to 1. And then we say, do that while the counter is less than 0. Well, it's not less than 0, so as soon as we hit this condition, the loop stops. Now, the key difference here is that if this condition were at the top, this would never execute. That's the big difference, right? So with a do-while loop, you always execute the body of the loop at least once. Whereas with a regular while loop, you might not even do it at all. Does that make sense? It's a subtle but important distinction. Okay, and then after we're done with the do-while loop, then we print confirm. I'm making a note here, huge success. Also a reference. Anybody know that one? Portal. Portal, that's right, yes, Portal. The song's still alive. Okay, so that's a do-while loop. But a lot of you have been asking me about this other thing called for loop. So, and yes, we're going to get to it now. So the way a for loop works is that a for loop is a counting loop. It's specifically designed to go through a range of values, often numbers, but not just numbers. So let's say we have a counter. This is how we construct a for loop. The way a for loop works is that we have 3 pieces. The first one is we have an initialization line of code. So in a for loop, this first part initializes counter to 3. Then we have a condition. This is the condition that has to be true for the loop to continue. So we're going to continue while the counter is greater than 0. And then we have an iteration instruction, an iteration statement. In this case, the iteration statement is counter minus minus. The iteration statement happens after the loop's body has been executed. So here's how it works. It executes the first part, it checks the condition, it executes the body of the loop, and then it executes the iteration instruction. Everybody follow that? And I'll say it one more time just to make sure everybody's following. It does the first part, the initialization, then it checks the condition, it executes the body of the loop, then it executes the iteration value. And then it checks the condition. If the condition is still good, it does the body of the loop. And then it does the iteration instruction. And then it checks the condition. And if the condition is still good, it does the body of the loop. You see how this is going? Okay. So the iteration is it's going to start with the initialization, check the condition, execute the body, do the iteration. Check the condition, execute the body, do the iteration. Okay, so that's how a for loop is constructed. So let's say that we had something similar to last time, but we're going to try and do it with a for loop instead. So while the counter is greater than 0, we're going to continue. So the first time we start, we initialize the counter value to 3, right? That's what this value is up here. And then we say, she's not dead yet, Jim, right? And then the counter iteration instruction executes. That's going to subtract 1 from counter, so it's going to go down from 3 to 2. And then we check the condition. Condition's still good, so we're going to print. And then we're going to change the counter value down to 1. And then we check the condition. 1 is still greater than 0, so we go into the body of the loop. So we print it one more time. And then we do the iteration. When we do the iteration, it changes to 0. 0 is not greater than 0, so the loop is going to break. And then we print out, okay, now she's dead. It's very important, I guess. Sorry. And then maybe we print out the vital signs. And let's have another for loop. This one's a little different. You might notice right here, I'm saying int vital count equals counter. What this does is it creates a new variable just for this for loop. This variable only exists in the loop, called vital count. It initializes it to the value of counter, which right now is 0, so it initializes it to 0. Follow so far? Then, while vital count is less than 0, it's going to continue, but it's not less than 0, right? So this is never going to execute because it's never in the range. Even though we did the initialization, it's never in the range. And so the last thing we do is we print out confirm. I'm making a note here. Okay, yes?
If you initialize the vital count in the loop, will it have to initialize every single time it goes through?
The question was, if I initialize it inside of the loop, would it initialize it every single time? And the answer is yes, that is what it would do, if you initialized it inside of the loop. Yeah, well, not only that, but as we're going to see in a minute, any variable you declare inside the loop only exists for that loop iteration, and then it disappears. Which means not even the whole loop, just this step in the loop. So it would be very counterproductive, is the short version. We're actually going to look at an example of that if we have time to get to it, though. Okay? All right, anyone else? Really? You guys are good? Yes? Good question. When I set it to counter, it actually will counter at this point as 0, right? Because we counted down to 0 right here. And so when we get to this line of code, it's already 0, so that's why it sets it to 0. Does that answer your question?
Yeah.
Okay. Yes?
So while variables you declare inside the for loop can't be used in others, the counter or whatever you use as a counter can be used for others as well?
Right. So if you do, I'm going to rephrase and answer your question. So if we declare a variable outside of a for loop, we can use it anywhere in the program, anywhere in that area. But if we declare it inside of the for loop like this, it only exists inside of that for loop, and after the for loop is done, it disappears. It's got its own. It's basically got its own stack frame. Is the way you can think about it. All right. Anyone else? Yes.
Okay, so a variable that's declared outside of the counter, or outside of the loop, you can carry on its value to other loops, but if it's declared.
Yes. So the question was, so that if I declare something outside of a for loop, that value can carry on from one loop to the other? And the answer is yes. But not if it's declared inside of a loop. Yes? Oh, that's a good question. The question was, why does the first for loop have brackets and the second one doesn't? And the answer is, because I wanted to demonstrate to you that you can have brackets or you can leave them out. You can actually do either one of these either way. The key is that if you have more than one line, you have to have the brackets. If you have just one line, you can have them or you can leave them out. Does that answer your question? Anyone else? Okay, so another thing we can do with containers like arrays, is that we can use another type of loop, another type of for loop called a for each loop. And the way a for each loop works is that it goes through every element in a container, in a set, and it will let us look at each one of those values. So we can do that with a for loop, and we can also do it with a for each loop. Oh wait, actually, I'm skipping ahead. Yeah, so I'll talk about for each loops in a second. So if we're going to iterate through with for loops, a lot of times what we'll do, and we saw an example of this before with a while loop, is that we'll have some index variable, and we're going to start that index at 0, and then we're going to keep going while that index is less than the length. So we looked at an example of this with a while loop, but this is the first one with a for loop. And then we might increment that index, bring that index up by 1 each time. So let's say that we were printing out the information about a particular potato, in this case. Then the first time we execute this loop, we start counter at 0. And so we're going to print potato number 0 plus 1 is 1. And then go to potato 0, which is ini. So potato number 1, ini. And then we're going to increment that counter variable. That'll go up, right? Index plus plus means that variable goes up. And so 1 is still less than the potato's length. What's the potato's length again? 4, right? So it's 4 because there's 4 values in it. And so now we're at 1, so we do potato number 2, 1 plus 1 is 2. And the potato at index number 1 is mini, so it's going to say potato number 2, mini. And then we continue the same thing. We increment this again. It's still less than the potato length, which is 4. So this is going to be potato number 3 is mini. And then we increment to 3. 3 is less than 4. Potato number 4 is mo. And then we increment this. Index becomes 4. 4 is not less than 4. Right? 4 is equal to 4. So at that point, the loop stops and it's done. So that's a for loop for going through an array. Yes?
Wait, so if the integer index is set to 0 for the for loop, and then the loop continues for as long as the index is less than the potato length. You set the index to add 1, and then you say you want to call the potato index. But then after that, you add 1 to the index. Shouldn't that go from potato 1 to potato 3 then?
So, okay, so there's a lot to unpack in what you said, so I'm going to step you through this. It's important to note that in this line, we're only seeing what the value is of index plus 1. So we're not actually resetting index's value. So if we were resetting index's value, we would have to use a plus plus operation like up here. So we're not actually changing the value here. So when index is 0, this is 0 plus 1, which is 1. But index doesn't change. Index is still 0. Then here, we go to potato 0. Does that answer your question? Yes?
If you did the for loop with index less than or equal to potato length, you would get an array out of bounds error, right?
Yes, the question was if we did less than or equal to potato.length, we would get an array out of bounds error, right? And the answer is that's correct, because you would be going past the end of the array, because the array's indices are 0 to 3. Okay. Anyone else? All right, I appreciate you hanging in there. I know that it can feel a little dry, especially when we get to the end of a 2-hour lecture block, and I can't speak anymore. So, for each loops, which is what I was so desperate to talk about, right? A for each loop basically is similar to a for loop, except you don't have to worry about indices, which is great. It makes it much easier to iterate over things and not worry about losing your place. So, this is the format for a for each loop. We say for, and then we give a name to the type, to whatever the variable is that we're going to be using, and then we say what container we want to use. So in this case, we have the container potato, and what it's going to do is for every entry in potato, it's going to point name to that entry. So first name will be E, then it'll be me, then miney, then mo. And it's going to do the loop for each one of those values. So it'll start by setting name equal to E. And then it's going to print out the potato is E. And then it'll move it to the next one. The next one is me. So now name is me, and it prints out the potato is me. And then it goes to the next value, which is mining. We get eeny, meeny, mining. And so name is miney, so when we do the potato is miney. That's what prints out. And then finally, the last value is it assigns it to mo, which is the last one here. And that's going to print the potato as mo. At that point, it will have finished going through all of the elements, and so it'll be done. So this works for arrays, but it doesn't just work for arrays. It works for any type of container, and we're going to talk about more of those as we move along. Any questions? Yes?
So you know that you can just initialize string name in the for loop again?
Yes.
Like you don't have to do it earlier?
Right. Okay, the question was, so I can just initialize string name in the for loop. I don't have to put it earlier, and the answer is that's exactly right. I can just create a variable just to the for loop. Yes?
If you wanted to move along, like, because it looks like your potato, it starts from the beginning, is there a way to move it to the next, like if you wanted to start from another part of the array?
Oh, that's a good question. The question was, what if you wanted to start partway through the array? And there are ways to do it, but it's a little bit more complicated. So there's some... I think the simpler way to do it in this case would just be to use indices, to be honest with you. But there are ways to do it. So, but they're a little bit complicated. So if you want to stick around, I'll go through.
All right.
Okay? Anyone else?
Oh, wait, video.
Yes.
Can you go back one slide?
Can I go back one slide? I guess so.
Can you do more than one index or integer?
The question was, can I do more than one index or integer?
Yeah. To keep track of like two variables?
You can, although for a for loop, it would be bad form to put more than one inside of a particular for loop. If you want to iterate over more than one value, if you want to go through two different values at the same time, like for two different indices,
Two at the same time.
then we would have what we call a nested for loop. And actually, I do have a slide for that, so we are going to look at that particular example, assuming we don't run out of time. Anyone else? Yes.
That man doesn't even pay attention. He doesn't even pay attention.
What's the difference between index plus plus and this index plus one? Is that what you're saying?
No, I mean, like, could you put it below that just like out, like index?
Oh, could I do this in a different place, you mean?
Yeah.
So for a for loop, I can't. For the way the for loop is formatted, this is just the way it works. It'll always execute it afterwards. It'll execute the body of the loop, and then it'll do the increment. But for a for loop, it's just, that's the standard format. Yes? That's a good question. The question was, you can see your C background coming out. Is there a difference between a string and an array of characters? And in Java, and even in C++ now, yes, there is a difference. The difference is mostly that strings are more complicated. They have some more information built into them, like the length, stuff like that. Stuff that in the C language you're missing. But there is a difference even in Java, yes. But they're usually easy to convert between one and the other, because they're very similar. Usually a string has a character array underneath it. Okay, so that's for each loop. This one's really handy. For each loops will make your life more pleasant if you use them where you can. So I highly recommend it. But let's talk about another question somebody had, which was, what if we had more than one index we need to go through at the same time? And in this case, I'm going to use a chess game as an example. Oh, look, it's that enumeration thing coming out again. And you'll see that I use enumerations a lot when I can because they make things easier to read. Yes, sir? The question was, is the difference between a for and a for each loop basically just the way you set up the loop? And the answer is pretty much, yeah. Like, that's the main difference. There's a couple of little mechanics behind the scenes that are a little different, but otherwise they're the same. It basically, for each is an evolution that sprung from the for loop, like in the development of languages. Okay, so I'm using an enumeration again here, and in this case, I'm using different types of chess pieces because I'm going to put stuff on a chessboard. So if I wanted to do that, I might start by creating a board of pieces where I have a board that's 8 by 8. Remember, everything defaults to null, so by default, most places will have null. Then I'm going to go through and I'm going to go through the y. I'm going to start with y being 0, so that's like the top row, right? And go from 0 to 7, which is, you know, the range of all the pieces along one row. And while it is less than 8, while I haven't gotten to the end, if y is 0 or y is 7, in other words, if it's the first row or if it's the last row, then I'm going to go across all of the x positions and I'm going to make them a pawn. Because the top, oh, I messed this up actually, darn it, I had this backwards. Okay, so it should have been if y is 1 or 6, because those are the pawn rows. I made a mistake. Yes, sir?
Why did you put int y on this line 9 on after the...
The question was, why did I put int 9 on this line right here? Or int y?
And y and the next one. Like, right there. No, up. On line 9, there's 2 int y's.
Oh, y...
Right. Go right. Right there. Right.
Oh, that's because it's a typo. Sorry.
Okay.
Yeah. Yep. You can see nobody proofread my slides today, so sorry about that. Yeah, it's just a typo. So does that answer your question?
Yeah.
Sorry. You know what? I'm going to fix this real quick. It's a small error. So, and I'm going to change these. I appreciate your kind words.
It's only Tuesday.
Yeah. I'm only one day into the week. Okay, so here I fixed it now. So so now it doesn't have the int there. So what I'm going to do is, if the row is 1 or 6, in other words, if it's the pawn rows, then I'm going to go through all the x positions for that particular row, and I'm going to set board xy equal to the pawn. Good so far? Okay. So otherwise, if I'm at the top row or the bottom row, if I'm at 0 or 7, then I'm going to set...
You can do that?
Oh, I made a mistake again. you can see I was tired and sleepy when I was making these. Late at night.
Last night.
Maybe? I don't remember what day is what day. One of these days you speak of.
What are days? Calendar. I just wake up, that's how I feel.
Hey, I rolled out of
You
bed
got it?
today and I came
You got
to
the whole
class
party?
and I consider that a victory. So.
Same here.
Okay, I think I got it right this time. I had to fix this because otherwise it would be hard to understand. So then, for each of those for each of the positions at the beginning of a row and at the end of the row, I'm going to set them to be a rook. If I offset by 1, they're going to be knights. Offset 1 more, it's going to be bishops. And then for the third position, on whether it's the top or the bottom, it's going to be the queen. For the fourth position, for the top or the bottom, it's going to be the king. Now, obviously, I haven't got the colors captured here. I would have to have another enumeration and cover both sets of values. Yes?
You didn't declare X in your nested for loop.
I didn't declare what?
You didn't declare X.
Curses! Yes. Yes, you're right. So, so I made a mistake here. This should have been int x equals 0. You can give me that one now, I think, right? So, okay. No? Wow, harsh. Oh, man. Somebody will be teachers someday.
You can do
terrifying.
equal. You can do equal.
Yeah, so equal is just to check to see if two things are equal.
No, like line 17 through 19, you do like...
Oh, yeah. So you can do pass-through assignments. So this is something I talked about very briefly at the beginning, but it was easy to miss. if you have a bunch of things that you want to set to the same value, you can say one thing equals something else equals something else. And you can actually chain these as long as you want.
Which one is being...
Well, this is the value, right? So this value goes in here, and then it also
Okay,
goes
okay,
in
got
here.
it.
Make sense?
Yeah.
Yes?
Can you do that instead of writing 4 to 7y like under?
Oh, yeah. The question was, could I just split these up into 2 separate lines? And I definitely could. Yeah, absolutely. I'm just doing it for shorthand because I have a limited number of lines. All right, anyone else? Yes? So, that's a good... So, I'm going to repeat your question. You said you thought for the 2 dimensions, the first one was the row. And this is why I think it's important not to fixate on this, because it doesn't matter what it is actually represented as in memory as long as you're consistent. So the reason I did it this way is because my convention for doing like graphics and stuff is 2xy. But that doesn't mean that that's how it's represented in memory. Does that answer your question? Anyone else? But don't worry about that. Like, really, the memory, someday you will have to worry about this. When you get into more advanced classes like operating systems, it will matter. But right now, it's more important to focus on the concepts. Yes? Oh, that's a good question. Yeah, these are all good questions. So right here, I don't have any brackets after the if statement. Does anybody know why I don't need those brackets? What do you think?
Is it because even though
Late at night.
really still one statement being processed?
Yes. So you're right. So the question, so the answer, what was your name again? Daniel. What Daniel said was, is it because it's actually just one statement? And the answer is yes. Because this whole for loop is treated as one statement all by itself. So because it's one statement, I don't have to have the brackets. I could have them, but I don't have to have them. The same thing is true here. For the for loop, there's just one statement in here. So I could have brackets here and brackets here, but they're not required. All right, I saw a couple more hands, but maybe they were all the same question. Yes?
Can you declare a board position, then a piece, then another board position, like in the same line?
Could I declare, the question was, could I do a board position and then a piece and then another board position? And the answer is no, only because the final value has to be on the end. So whatever you have all the way at the end, that's what everybody's going to get. Does that answer your question? Anyone else?
Hey, sorry. Can you repeat
Yes.
the brackets, braces thing?
The brackets thing, yes. So, the key thing for ifs and fors and a lot of these conditional statements is that if the statements inside of it are only one statement long, then you don't have to have brackets. It's only if you have more than one statement that you have to have brackets. And so the for loop is just one statement. Even though it has other statements inside of it, it's only one statement underneath the if. And so you don't need brackets here for that reason. And the same thing is true for this guy, right? This assignment, there's only one statement inside of this for loop. Does that answer your question?
Yeah, I think so.
You could have the brackets, you're just not required to have them. Okay, anyone else? Yes?
Just don't understand what's happening in line 11 and 14.
Okay, yeah, line 11 is a little bit complex. So basically what I'm saying is, if we're at row 1, which is, we have 0 and then 1, if we're at the second line, or if we're at row 6, remember it goes through 7, so 6 is one above that. In other words, if we're in one of the lines that is just pawns on a chessboard, do you follow so far?
Yeah.
So if we're in one of the, that's what this does. It says if we're in one of the pawn rows, then we're going to go all the way across the row. We're going to go through all the x values from 0 up to 7, and we're going to set it equal to a pawn. Does that make sense?
Yeah.
All right, anyone else? Okay, so we have just a couple more things to handle here. We have 3 more slides, and then I'm going to let you get out of here, okay? So, sometimes we want to stop a loop in the middle before we finish it. We just want to be like, okay, I'm done, because I found whatever I'm looking for. So let's say, for example, you were trying to find a particular character in a string. This looks like it might be useful in our project. Maybe. And the next one will be even more useful. You'll see. Incentive for sticking around. So, in this case, we have a string and we have a character that we're trying to find. So what we're going to do is, the first thing we're going to do is we're going to take our string and extract a character array from it using the two-character array method, and that'll give us an array of characters. Then we're going to have an index we're going to track. We're going to start it at 0 while we have not reached the end of the characters. We're going to increment that index. If the character is the one we're looking for, right? If character index, if the character at our particular index is the one we're looking for, then we're going to do a break. So we're going to go through until we find a character that's the one we're looking for, and then we're going to stop. When we stop, because we declared index outside of the for loop, when we stop, index is going to hold the value of the thing we were looking for. And then we can return the index. So this is that ternary operator again. So the index, if the index is equal to the length, that means it got all the way to the end. That means we didn't find it, so we're going to return -1. Otherwise, we're going to return the index. So in this example, if we pass in the string potato and the character O, what do you think the answer is going to be here? It's going to be 1, right? So we have position 0 and then position 1. It's going to find the O, and it's going to return a 1. So when we say it breaks, it means the loop stops immediately. It doesn't keep going. It doesn't keep iterating. Do not pass go. Do not collect $200. Right? Stop immediately. That's what a break statement does. So as soon as what happens is it's going to go to the P, and it's not going to find P does not equal O, so it's going to keep going. It increments it again. Index is now 1. It checks the character at index 1. That's 0. O. O does equal O, so it's going to break. The index does not equal the character's length, so it's going to return the index itself, which is 1. For this other example, is there an E in potato? No.
-1.
Dan Quell thinks there is. You guys you're probably too young for that, right? So Dan Quell was vice president of the United States under George Bush I, and he went to a spelling bee. And he corrected a little girl who spelled potato without an E. And he said that she needed an E at the end.
Oh.
Oh, wow.
That's a true story, by the way. It was nationally televised.
Roasted.
Yeah, anyway, so that's what this is a reference to. There is no E in potato, in case you were wondering. So if we're looking for E, what's going to happen here? So we get in here, and, oops, I figured it. We get in here, and we're going to go through all the characters. We get to, this last position. It's still not going to be equal to E, so we're never going to hit this break. When we get down here, the index will equal the character length, so it's going to return -1. Any questions? Right, so it keeps going back to the top of the loop until it reaches the character. Yes?
After for example, it says that we need to find O, but what if we want to keep finding O until the end?
That's a good question. What if we want to keep finding O until the end, like find the last one, right? Well, there's two ways you could do that. You could start at the end. That's one way you could do it, count backwards. Or you could have another variable to track it, but probably counting backwards from the end is the best way. Okay, so this is the part that I think will actually be useful to you in your project if you haven't figured out a way to do it yet. And you don't have to use this, it's just an example. A continue statement lets us skip the rest of this iteration of a loop and move on to the next one. So it doesn't stop the loop, it just stops this block. It goes back to the top of the loop. What continue does is it skips back to the top of the loop we're on. So let's say that you needed to count the number of characters of a certain character type in a string. Then you might do something similar to last time, but there's going to be a subtle difference. So we're still going to grab the string as a bunch of characters. We're still going to go through the indices. But what we're going to do is we're going to say, if this character is not the one we're trying to count, then we're going to continue. Then we're going to skip back up to the top of the loop. Only if it is the one we want to count, we're going to do a ++. So we have this variable count that we're going to keep track of, and every time we hit a character that is the one we're trying to count, we're going to raise that number. So the first time it'll go to 1, the second time it'll go to 2, and the third time it'll go to 3. And then we're going to return the count, whatever number we have. So if we have potato, and we're looking for O, when it hits this one, it's going to increment it from 0 to 1. When it hits this second one, it's going to increment it from 1 to 2. And so the value of count is going to be 2, and that's what it's going to return. And potato, which does not have an E in it, if we try to count the number of E's, what's the result going to be?
-1.
It's not going to be -1, it's going to be 0, right? Because there's nothing, right?
The only reason I would speak like with that is it's 0 counted still in the array, positioning of the string.
Well, you have to distinguish between when we're counting how many of something there is and what index they are at. Does that make sense?
Okay.
Just like the number of characters is different from the index of the first character. Anyone else? All right, so last slide. The last thing we're going to talk about here is the scope of variable. Oh, I'm sorry, go ahead.
I think we did that.
Where's count?
Yeah, I don't think you defined that.
Yeah, it's up there.
Where is it?
In count.
Oh, count me. That's the character that we passed in.
Oh, yeah.
Does that answer your question? Okay, so the last thing I want to talk to you guys about is variable scope. When we talk about variable scope, we mean where is a variable valid? What are the places that we can use a variable and that we can access or change its value? That's what we mean when we talk about the scope. So, the scope of variables differs based on how you declare them and how they come into the program. So, for example, the parameters or the arguments passed into a method, those have method scope. They're valid for the whole method. That's also true for anything we declare at the top level of the method. So, cards, target, and count me, these are all method scope. They have the scope of the method. What's interesting, do you remember when we talked about the heap earlier and how like all these objects are on the heap? And that's true, and the actual data itself, this is an important distinction, the data, not the reference, but the data itself has global scope. If you can get an address to that data in Java on the heap, then you can use that data. You can modify it and change it. So the data itself has global scope. In this case, this particular identifier, characters, that one has method scope. So that's an important distinction between the data and the reference to the data. Now, index right here, I've declared the index inside of this loop declaration. That has loop scope, right? That is limited only to being used inside of the loop. If you try to access it outside of the loop, it won't work. And finally, this is the most limited scope, this variable iExist right here, this bool. This variable only has iteration scope. That means as soon as this block of code completes, even still within inside the loop, if I go and I start again, this one, once I reach the end of this code, that variable disappears. And then at the top, we create a new one again. So it doesn't hold its value, it just disappears from existence and a new one appears. Yes. It's kind of like, well, it's kind of like Mr. VC's, right? It's done to its job, it disappears. So these are the 4 scopes we're going to be looking at immediately. We're going to add on to this list as we go. But it's really important to note that down here, outside of the loop, neither of the loop-based variables are valid. All right. If you have any questions, let me know. Take care. I'll see you Thursday.